so for question number 4, this is a long one. A sample size study is conducted involving 15 infants to investigate the association between gestational ages at birth, which is our X, measured in the weeks, and birth weight, which is our Y, measured in grams. So we were provided this chart here, which provides, the weeks and the birth weight in grams. And basically the first question is calculate the Pearson sample correlation coefficient R and interpret its meaning. So I'm going to do this tedious chart here. We have X is our gestational age, which is our weeks, which is our independent variable, and we have our birth weight in grams, which depends on the age, etc. So we have our X column, which is given to us, which is our gestational age in weeks, and then we have our Y, which is our birth weight, and then we are going to X square it, Y square, and then the sum. So like X times Y. And then down here I have the totals, which we'll get to that in a minute. So we are basically going to punch all of this in to a lovely equation here. I'm sorry, it's kind of messy, but basically our correlation would be the sample size times the sum of xy minus the sum of x times the sum of y, over the square root of n times the sum of x squared minus x squared, times the sum of x squared minus x squared times n times the sum of y squared minus y squared. So you plug all that in into the equation here, and we get 0.8793, and that is our R value. So I just wanted to put that out there. But there's an easy way, if you didn't want to do a total, like put it all into one equation, is you can also do the sum of x over n, which would be 38.36. And the way I found that is because the sum of x, our total is 575.4, and then our 15, we get that because we're involving 15 infants. So you can do it that way, and you get your 38.36. Same thing with the sum of y over n, you get, your 22976.6. So forth. You keep going all the way down, x squared, y squared, and then you multiply them. And then I have these numbers here. We basically just punch it in like I was just doing. So like I was saying, the correlation coefficient of R is 0.8793. And basically we can interpret, since R is 0.8793, we say that there is a strong positive linear relationship between gestational age and birth weight, because it is greater than. So